Next up, we have PwC talking about how to start an enterprise level simulation. Please welcome Cindy Ma and Sandy Burns.
Hello.
Hello.
Hello, how are you? Right, so Cindy and I are going to talk a bit about how, and this is more sort of how do you organize a project, and like how do you set up a project to get to the endpoint you want to get to. So it's how do you start enterprise simulations. So introduce ourselves a bit in a second. Like how is doing an enterprise project different? What is the approach that we've come up with from doing this, for a number of years now? And then, for you all, what are sort of takeaways, or what are the things that you can be paying attention to when you are moving into a problem like this? Okay. So I'm Sam Burns. I'm on the left there. So yeah, I've been at PwC about 10 years, and I came from academia, so I had a PhD in applied math and doing differential equation modeling and whatnot. And mostly I work like in healthcare simulation work and looking at different types of statistical methods, data analysis, and so on. Go ahead, Cindy. Yeah.
And I'm Cindy. I've been working on simulation models for about a decade now. Just about all of that has been in AnyLogic. So at this point, it's really all I'm good for. So let's dive in then. So what do we feel distinguishes enterprise simulations from other types of simulations? So we bucketed them, the factors, into 4 categories here. Firstly, the major thing is that the environment that you have to develop these simulations in is quite different. They'll often rely on integrating into other existing systems like SAP, lots of data sources, and other machine learning models. Also, the nature of them kind of necessitates having lots of environments. So a development environment, a test environment, and a production environment, so that you don't lose the ability to use them while you're improving them. Probably you're going to have multiple concurrent users, and this increases not only your user scale, but they are going to generate lots of data that they may be expecting you to store as well. And of course, then you might also have to deliver this model through a custom UI that's tailored for each user persona as well. So the environment that they're developed in can become quite complex. And then naturally, then that means that the project management is a lot more difficult. Straight off the bat, your PM is going to have to be coordinating between data teams, IT, modeling, and business teams. And that's something you have to get started with right away, because if you don't have the right environment set up, it becomes difficult really quickly for these kinds of models. The other thing to consider is that if this model is successful, then you're going to have a long-term project on your hands, because the successful model means that people are going to want to continue iterating on it, and it can't have downtime while you're continuing to improve it. These types of models are also really easily subject to eroding goals, which really affects your PM, because then, so basically over time, we feel that because of how many groups have to coordinate and work together, any blockers are likely to be seen as, oh, we can maybe compromise on that. And then by the end of the project, you may not recognize the model anymore as what you started out trying to accomplish. And then finally, you need to, if you don't have the existing infrastructure ready, then the maintenance becomes really difficult, and you're going to have to factor in a lot more time to work around whatever the existing infrastructure is.
Okay. And then on the actual modeling side, something to keep in mind is we have an agent-based model with agents and interactions. If you run that at a small scale, or run that like with a smaller number of agents, and once you scale that up, it doesn't always scale linearly. You can easily end up with a model that sort of becomes computationally intractable. So it's something to think about when you're scoping out a model. Organizationally, it can be really difficult to, as a group, come to, even before you start modeling, to decide sort of, what is the problem this model is going to solve. It sort of seems like an obvious thing when you're usually working with just a small group of a few people, but when you get to this sort of larger groups of people, or organizationally, that actually, we find it's actually really worth the extra effort to spend the time really pounding that out and really getting that clear. Yeah, it can be difficult to grasp the most appropriate scope and scale for solving the problem. That's true too. It's sort of, once you define the problem, then you have to kind of say, what kind of model can I actually build in the time and, sort of computationally tractable, again, type of model to solve that problem. And then also, the nature of the problem that the model is solving. So is this like a decision-making tool that they're using for a strategic purpose, or to make, looking at where they might be going from here, or is this actually something that's going to be implemented, or sort of at their enterprise level? That's actually something they're using systemically in their organization. Again, expectations. This is another thing that you have to get on top of right in the front. It's easy for the stakeholders who may not be technical, to think that this is sort of a magic bullet, that this is a magic box and it's going to solve everything. So you have to really establish up front what this model is going to do and what it's not going to do. To be successful, like we'll talk about this in a while, is constantly being in contact with the client, with their team as we go along, so that they don't forget or lose track of what their model is supposed to be. And then also making sure that as you go along, that you're keeping in touch with them about what you can do, or as things come up. And then, like Cindy was touching on, is how the models are not infinitely extensible. So it's they are not thinking about the computational load or how the nature of the model changes if you want to scale it up. And so there is some expectations around how much you can scale this model from the beginning. Okay. Right. Let's see. How do we need to tailor our approach to enterprise solutions? So, the reference point here is to say, if you're just building a model for a small group of people locally on your own machine to kind of explore something, like what is it that we need to do differently here? So this one's important. And I sort of like reading these and just thinking backwards in my mind all the times I've done all these things. But you have to make sure that the model you build fits in with their current collection of models or data analysis tools, or how they store their data, and that you're in contact with the people who are the experts in their group, so that they understand what this model is and how it's going to be used, and that you understand how they have their architecture set up. Don't underestimate or do overestimate the number of users, or as much as you can, the usage of the model. You don't want your model to go up and then immediately crash because there's 10 times as many people using it as you'd planned for. Model scale. This is the same thing that Cindy was mentioning earlier, is don't let your model sort of erode. Oh, no, this is the one about scaling it up. Sorry. This is one about scaling it up. So if you develop a model locally on your computer and you think it's all doing great, and you're just expecting it to scale linearly when you use it and deploy it, that's not always true. Sometimes the complexity or the computational overhead of the model scales non-linearly as you scale it up. So you need to be actually setting up your dev and your production environments and testing out your model at scale, on the cloud from the beginning, because that actually can sort of change the whole topology of your model. Make sure that in the interest of trying to get through the problem, you don't throw out the baby with the bathwater. Make sure that as you are making adjustments to your model, as the data you're using is changing, as the sort of what you're able to model is changing, that you're keeping an eye on the outputs that you need from the beginning. Write down everything and all the problems in the aims and sort of changes to them as you go along. This is really important because everybody forgets that you had a discussion about how you couldn't do that. And then at the end, they're like, where is this thing? And you're like, remember? They're like, no, I don't remember. All I remember is that it's not here. So you really need to kind of keep a log, keep up to date, keep a backlog of what's going on with the model development. Keep an expectation about what versions or what pieces of the model will be ready at what times. And as that changes, keep track of that. And then we said earlier, like, things are not infinitely extensible, right? So keep some expectations about how scalable this model is. And then the idea is on the right here is to say, like, which of these things do you need to do up front? All of them, right? So this is like the earlier you can do this stuff. I mean, a lot of the stuff is just maybe even before you start, as much as you can, even before you start modeling, right? It really is important to have to do a set of work that actually you can accomplish, and at the end, your client or whoever you're working with feels like they got what they were looking for. Okay. All right. So again, like I said, this is sort of our approach after having done this, for a number of years and for a lot of different projects across. One thing with being at PwC is that we're working across all different kinds of industries, with all different kinds of clients. So this is our methodology that we try to use as much as we can and in response to all those problems. So the first thing is, and again, sometimes this feels kind of pedantic or slow, or I just want to get to the model, but it's funny how this simple thing can be misaligned right from the very beginning. So it says to say, we think this is true, and these things are ways to measure it. Ideally, those things change in reasonable ways under different conditions, and then say, what impacts those metrics and under what conditions, and then what are those things that you have control over. So that's kind of abstract, but here's an example of what we did recently, and we're actually writing an academic paper about it. But during COVID, patients were deferring healthcare visits for chronic disease, and they were deferring treatments. So it's to say, what is the effect of this behavior on disease management progression, as observed in claims data? So that's our metric here. And then we wanted to say is, the client wants to know, sort of diagnose that, say what's that, and then they were saying, we have a certain number of things under our control that we can intervene, and then say, what is the effectiveness of these interventions, in reducing the negative effects on patients' health. So having that set up ahead of time before you do anything, and then corrections to that as like a ground truth or a thing that you carry along with you, is really important, because then you get to the end and your model does that, everybody agrees that's what the model is supposed to do, and then you're moving along the way you planned. Okay, Cindy, I think
So
from here. Yep.
yeah, so we start with that problem statement, and then what we do is we run what we call a systems thinking workshop. It's part one, a prep and training session, really. So we have a set of slides that we roll out each time, and we're introducing people to a lot of systems thinking concepts, teaching them about variables, relationships, what feedback loops are, and basically the causal loop diagram methodology. And then this also gives us, in this preparatory workshop, we bring along that problem statement and make sure we confirm it. So now everyone has been introduced to it and is getting comfortable with it. This also usually happens a day or 2 days before the proper workshop. And so that gives people a little bit of time to actually think about that statement. Also, in this prep session, people will start to realize that maybe there are some people that were left out of the workshop list that really need to be there. So it's a bit of a last chance to add people too. And then we have the actual workshop. This is an adjusted version of a pretty traditional group modeling exercise. We've added in some design thinking concepts, and this is something that we're constantly updating. But we find that this really helps us arrive at a consensus. The goal of this workshop being to arrive at an agreement on what the system actually is. It has to be visual and explicit. All the stakeholders in the room agree on this at the end of the day. When we walk out of this workshop, we aim to have what are the output metrics that you can really use to answer the problem statement. So things like identifying those levers and what those levers are meant to change. That's what we walk out with. And then this has worked better for us in person, but of course with the pandemic, we switched over to using Miro and then also Google Jamboards. Also, not everyone can be present in person all the time. So we often have this as a way for us to record what we did. So let's take a look at some examples of what we get out of these workshops. So it's not always a causal loop diagram. You can see on this left one, this was looking at a customer retention case, and those are just this flow chart that we've ended up with. You might be able to tell that that model ended up being more discrete event and agent-based. The middle one is a causal loop, very, very busy. These are all intentionally small so that you can't see details, just so you know. So this middle one was about organizational growth planning. Because it's a really big scope, a really big subject, covers lots of areas, and those are all the shaded bits. And then finally on the right-hand side, there's one about strategic infrastructure planning. So you can see the variables collection is one key thing that we do. And we collect a lot of variables which get voted on by the participants, and then we end up with a draft mental model that we see on the right. So we walk out with these kinds of artifacts from this workshop. We summarize everything that we got from the workshop, and then we produce you could call it a package of written goods that we read back to the stakeholders. And this is the chance for them to say, well, that's not actually quite what we meant. You heard us wrong. We want to restate it, any of that kind of stuff, so that we end up starting from the right place. In this package, we always have what is the problem statement. It needs to be very explicitly stated. We want it in prose. Don't want it, like a couple of dot points and then left open-ended. We want a visual representation of the system, like the examples we just showed. A variable dictionary, which is often just all the variables that were put down, but now we need to apply definitions to them. And then a high-level data request. This is really important because the next step is to get sample data, which is really crucial. And then we need to have a handover plan and a long-term plan for the model, this so that we know who is going to own this at the end of the day, so who the end users are, who's going to maintain it, how frequently are we expecting data updates and calibration updates, and then optionally wireframes depending on the type of project and who the end users might be. So this list seems kind of long, and this is before we've really embarked on the project, right? This is like day 2 in. We've had a prep session and we've had a workshop, but usually this ends up being less than 10 pages, and it's something that's supposed to be read back in a single session to get feedback. Okay, so step 4 then, now that we have the high-level data requirements, really crucial that we start collecting sample data right now, because we have to immediately perform an exploratory data analysis on that. We need to assess it for usability. Sometimes here we discover that the problem statement, the we thinks and the we feels in the workshop are not actually backed up by the data. We find that different teams are understanding say the definition of who a customer is, maybe they're understanding that very differently. And so seeing actual data, seeing actual numbers really helps us sort out those kinds of issues. This is also, of course, a good chance for us to rectify the problem statement or the purpose of the model if we need to do that. And then finally, there is a gate for us to decide whether or not to proceed. We have what we call a qualification guide, which is a whole list of more checklist items that say, like, have we answered all of these questions? Do we know what we're doing before we actually start? All of these questions should be answered in steps 1 to 4, but this is, of course, a good chance for us to follow up on those things. So one question that we might often ask is, like, why would you stop? When do you stop? And here it's if we can't really agree on the problem statement, maybe the stakeholders decided they want to go back and think more about which problem statement to prioritize, that kind of thing. Maybe there's no feasible way to incorporate the model into an existing process. So maybe even though you've identified the team that you want to help and the end users, maybe there's no way to incorporate it into their process. And so at the end of the day, after you build this model, still no one is going to use it. And then finally, if other methods that we find are more suitable, so maybe it's actually a machine learning problem, and so we shouldn't be trying to solve it with an enterprise simulation. Okay, Sam, back to you.
Sorry, I was on mute. So yeah, so just to wrap up and say, like, here are the big points or the takeaways or the things to be thinking about, from what we were talking. So yeah, planning is crucial. That means sort of writing things down, meeting with the clients, keeping in touch with them. You have that problem statement, that can grow into a paragraph and that you all agree on. Coming from those design sessions, have a diagram of what your model is. Where are the loops? Where's the nonlinearity? Where's the flow? Where do the agents go? What are the outputs? Variable dictionary there that also sort of establishes, like, what data are we going to use, what the output of the model is going to be. Interestingly, there's a whole thing around designing scenarios for the model, and that's like another thing that you can do up front or later on too. And what are the controls? I think that's another thing we didn't really mention explicitly, but as part of that design of the model is what controls are you going to have in the model. And the sample data analysis. Sometimes, and Cindy was talking about this, you get a hold of the data are not going to support the kind of model that you had been talking about to date. So even before you get too far down the lane with the model, go reviewing the data, seeing if the data actually supports the model you want, either then updating the design of the model or seeking more data. That can be a sort of a block there too. So then the critical part here is don't just go off then for a month, work on the model, and then come back and hope that what you've done still tracks with what they're thinking. You have to be in touch with them as much as you can. A lot of times also as their thinking's changing or the problem they want to solve is sort of maybe changing some too. So you want to be able to accommodate that as best you can. But ultimately you want them to have, to be happy with the model you're building and that they're not surprised. But then they also don't think that it's, like I said, it's not something magical, but they can kind of see how it actually works and understand what the limitations and what is actually information that's in there. This one is on the other side, is like when you're actually building the model, resist the temptation to add complications or complexity in the model just because you can or because you have the data there to do it. That can kind of come back and cause more problems for you later on when you're calibrating, or now you've introduced some additional feedback that sort of is making the interpretation of the results harder. Wait until you get to the end of a phase, like a sprint or a phase, where you can kind of review whether that's something reasonable to add. Again, and so then at the very beginning, say who's going to use this model, how are they going to use it, what are they using it for? Is there a dashboard? Is it Tableau? Is it, what kind of controls they're going to use? What is the output of this? Does there need to be like some sort of CSV thing that they're going to export? Is it just the, some sort of answer that the model gives them directly? That's really important up front. And then, again, the same thing that Cindy's been saying is make sure it fits in with the processes and the way that they have structured, how they are doing their, if other modeling work or data analysis or, even Excel things, so that it's not just sitting outside of their whole business flow or their architecture for how they do stuff, because then you give it to them, they're going to put it in a drawer, and then, that's not useful to anyone, right? So, okay, we'll pause there. We can take some questions from here. Let's see. A few seconds ago, what limitations could you mention about your model? Like the limitations. Oh, okay. Limitations of the model then are, it's sort of interesting. Some of these models are, like Cindy was showing those diagrams. Some of them are simple. And a simple model is easier to fit, easier to understand, is easier to build, and easier for someone to use. So if a simpler model gets the answer you want, then that's okay. Bigger models take longer. A lot of times we'll do it like in phases. So we'll do like a couple months thing to build a simple model, and then sort of negotiate additional phases of complexity as is useful to them. And they might say, okay, this is enough for now, and they might go use it and come back like 6 months later or something like that. Let's see.
The simulation demand that we forecast for PwC.
Oh, do I take that one?
That's such a tricky one to answer. Where we have no free time at the moment.
Oh, yeah.
but I wouldn't dare comment on the future.
It's hot and cold, it sort of is like everyone sort of is like, oh, we need to go make sure that people understand we do simulation at PwC, and then all of a sudden everyone knows, and now we're totally sunk, and then we don't have enough people to do simulation. So we are trucking along. Like I said, we work on all different industries, and a lot of the stuff is like, as you understand, like building different models, you can't just use the same model with every project, but we do try to keep our sort of templates or environments, or way we structure our variables, or the way we structure the different materials consistent. That allows us to kind of work through a problem methodically. Do you have clients with standalone solutions that wanted to transform the simulation to a more enterprise solution? Could you talk a little about the transition? If so, Cindy, why don't you answer that one?
Yeah, I think, yeah, so definitely if a model was built to be a little bit more extensible and then it was actually adopted, then naturally it just becomes bigger and bigger. And then sometimes it kind of scope creeps into the enterprise solution. We were actually going to ask if, seeing the list that we had of distinguishing features, if people felt like they had been asked to do a simulation, but it's ticking so many of the boxes that we mentioned that actually maybe they're building something a little bit bigger than originally intended. So I think that definitely does happen. For us then, you have a choice. You can start again because you feel like what you built maybe morphed a little too much and you want a clean start, but you can reuse a lot of what you did. Or hopefully you employed really good best practices from the beginning, really good object-oriented thinking, agent-based modeling, good Java practices. Then it's really not so difficult. We've definitely extended models beyond what we originally thought they would do. And a lot of that is just making sure you have a good, again, those environments, the dev, test, prod environments or demo environment, if that's what you're actually doing. Having the environment set up is really crucial to being able to transform anything into something bigger.
Let's see. if you have already done all the steps and have already built the model, what are your best practice in verify and validate your model? And what if you realize your model doesn't answer the problem statement? Okay, so verifying and validate, like, sort of that's a whole separate, sort of technical exercise. So um, I'm not going to get into that. The other one that was more interesting for the purposes of what we're talking about here is you get to the end, and for whatever reason, you didn't follow all the very important steps we spelled out here, and your model like is not tracking to what you initially set out to do. This happens a lot. I mean, this not a lot. This is the whole reason why we have this whole methodology. Is this thing does really happen? So in that case, I mean, what I would recommend is to say, what does the model answer? And then make sure that you're able to demonstrate that it has value, even if it's not the exact thing you set out to do. And then say, how does this project onto the initial statement? How can you still use this model? And then what way could this model get back to the thing they want? And it might be that you couldn't answer the original statement because you didn't have the data, or it's too broad a statement, or there's probably a reason why you got to the place you got to. And so examining that and talking through that is the best way.
Yeah. I would also say you really should have been keeping the stakeholders with you the whole way, right? So hopefully, if there was an evolution of the problem statement, unintended or otherwise, the stakeholder was with you for that journey. So they recognize why and how you ended up here. Maybe you solved a slightly different, but actually also still very important question. And then now you maybe have to add on, so you have to extend in order to also answer the original problem statement. But hopefully it shouldn't be a mystery how that happened.
Okay. How large is your simulation team at PwC in the USA? It's a good question. How big is our team right now?
Oh, thousands and thousands of people.
Thousands. Thank you. No, so we have tens of people in the USA, I would say. And then we have a large group that we work with in India, and then also in Shanghai. Yeah, and then we also have people unofficially who actually are, who are like us but don't actually happen to be in our group, that are actually sort of more traditional consultants, but are. And so there's tens of people like that also that sort of unofficially are part of our group. So.
When should an enterprise internalize simulation as a function? I would say nowadays people are probably more internalizing digital twin capability as a function, and then simulation is one thing that people view that you can do with digital twins, along with, as we saw earlier, emulation. So probably, yeah, the trend, what's hot now is to start from digital twins.
This is also a good question, though, when you're setting it up, is to say, is this model a model that is a finished product that they're just going to use and that you are going to maintain, or is it something that they actually have a team to maintain and they're going to use this as like a catalyst to get them started doing stuff? And that sort of changes a bit, like maybe how you build the model, or how sort of along the way, who needs to be involved from their side in understanding the structure of the model. And when you hand it off, documenting it and sort of looking at the path forward for it. So, we do different things, on the decision making and strategy things. They do one particular thing, we're running it, they have it to run, but they're not developing it further. On the things that are more sort of enterprise things, that are more organizational processes, a lot of times they have people, and and you're all here too. I mean, a lot of times they have people who actually, are trained to run AnyLogic. They have AnyLogic licenses and so on. So that can happen too. So they hire us to kind of come in to get them started and kind of get the timeline or the path forward, structured.
Is the simulation team part of a larger analytics group at PwC?
Yes.
We're in the what's called the Innovation Hub, which is AI, XR, other metaversey Web3 topics, and we're included under AI. And our claim to that is probably that they need us to do reinforcement learning. We do just deliver a lot of quite more traditional consulting projects using simulation.
Yeah, it comes up a lot. Is sort of we kind of get involved in different ways. We don't, I think we're up, but there are projects that are more Excel projects that traditionally the consultants kind of deal with, and then occasionally there are projects that come up that require more complexity or something, or either some Python programming or some AnyLogic programming, and then we kind of come in on those. So okay, I think that's us. Thank you for all your questions, and thank you for listening to our talk.
Yes, thank you, Cindy, and thank you, Sam.
Yeah.
Thank you for talking about enterprise level simulations.